Let's get a full screen here. All right, daily quiz 2. So the first 3 problems are the log rules. Try to use the simplest situations possible in order to see them. And then the last 3 are using your log rules to manipulate some mathematical expressions. All right, so rule number 1. Everyone should be familiar with e to the 0.7 equals 2, approximately 2, and e to the 1.1 approximately 3. All right, so ln of 2 plus ln of 3 is going to become what? Let's find out. All right, so let's look at 2 times 3. 2 times 3 is 6, okay, which could be written in e notation approximately as, I should use an approximation symbol, 2 e to the 0.7 times 3 e to the 1.1, approximations. Rules of exponents say that this is e to the 0.7 plus 1.1. And what is 0.7? The ln of 2. And what is 1.1? The ln of 3. Because those statements are saying, what do you put on top of e to get 2? Well, there it is, 0.7. All right. So e to the ln 2 plus ln 3 gets me 6. It's over here. It's what we started with. So these additions get me the exponent on top of e. That gets me 6. So multiplication of quantities, 2 and 3 are the quantities I used in the multiplication. If I change it to e notation, then these are the exponents that produce that quantity. So multiplication means that you can write it as a single log using multiplication. Rule number 2. Let's look at the ln of 6 divided by 2. What's that going to equal? The ln of what? Well, maybe you're already looking. 6 divided by 2 is going to get us 3. And let's see how. We just showed that 0.7 and 1.1 is 1.8, approximation again. That's the exponent that gets us 6. E to the 0.7 gets us 2, approximately. And this is a subtraction. Division implies subtraction. So therefore, what's another way of writing ln of 6 divided by 2? Ln of 6 minus 2 gets me 1.8 minus 0.7, which is 1.1. And 1.1 looks familiar. Barely see that, but I think you can. That's the exponent. And we find it on a calculator that way. Okay, so, and I think you can see that 6 is e to the 0.7 times e to the 1.1. I hope you can see the cancellation as well, right? But that's the ln of 3. And ln is all about the exponential activity base e. All right, and so I can boil this down to the ln of e to the what? 1.1. So what's the answer to that? 1.1. Rule 3. ln of 8. I'm going to show that that's the same thing as the ln of 2 cubed. And I'm going to show you that that's the same thing as 3 times the ln of 2. So 8 can be written as 2 cubed, 2 approximately, again, e to the 0.7 times 3. When I use this command, I'm only looking at the exponential activity, base e. Well, I've got some base e exponential activity here. And it looks like it's 3 times 0.7, which is the same thing as 3 times the ln of 2, approximately. Okay. So what's the log rule? The log rule for log base b of, what do I want to write here? Of b to the n is the same thing as n times log base b of b. In other words, power to power is a form of multiplication. And ln of 2 is an exponent. And I think it's that exponent approximately. So I hope that the numbers speak for themselves. So how could I write the following as a single log expression? Well, I do believe this 2 we said can go here, which means this 1/3 can go there. Now, maybe I should have rewritten this so that you can see it in steps. So that's the same thing as 7 squared minus the ln of 8 to the 1/3. 1/3 means the cube root of that. So that's 49 minus the ln of, this is the same thing as the cube root of 8. So this is the ln of 49 minus the ln of 2. And we said a subtraction of exponents comes from a division of quantities. That's a single log. And it came from that line of work. Now let's expand. Oh, we got another division problem. Maybe I should change it to a multiplication. Now let's leave it. Yeah, let's change it to 25√3. Okay, since we did division before, now we're doing multiplication. So I think we can start with the ln of 25 plus the ln of the square root of 3. And why don't we write the square root of 3 cut to the chase as a 1/2? And then we have the ln of 5 squared plus that 1/2 can go in front. It's one of your log rules. And so can this 2. So final answer, 2 ln of 5 plus 1/2 ln of 3. Okay, so the ln of 5, if this is an approximation, I can do 2 times 1.6 plus 1/2 times 1.1, and I can get a feel for this amount. As long as I'm working locally, we can do this. Last one, and of the last 2 problems, and this is the third, I'll ask one of those 3, and I'll ask one of the 3 that we started with on Rule 1, Rule 2, and Rule 3. And I'll ask you to show me how you get your answer on those first 3 problems. One of them I'll pick, and I want you to write a little something on your quiz that shows me you listened to this or you watched this video. All right, so I see an addition of exponents comes from a multiplication of quantities. So this could have been written as a single expression. X times x minus 2 is x squared minus 2x, and that's equal to 3. We change to exponential form. That quantity is represented by this calculation, 2 to the 3. And that's 8. So I solve quadratics by bringing the 8 to the other side, setting it to 0, and hoping we can factor. And I think we can. X minus 4 times x plus 2. I have 2 possible solutions, 4, comma, -2. I'm not going to use -2. I cannot perform logarithms on anything in the parentheses that's not positive, right? Logarithms are really the inverse of growth and decay. If I don't have something growing, that's what this x represents, something growing or something decaying, and how much you have, then I can't express it exponentially. Right? There's got to be something there. So -2 is discounted. 4 should work. Let's see it work. What's the exponent you put on top of a 2 to get a 4? A 2. Let's put the 4 in here. 4 minus 2 is 2. What's the exponent you put on top of a 2 to get a 2? A 1. Oh, yeah. And 2 to the 2 plus 1 does appear to be 8. And so the exponential activity here does add up to 3. A little awkward at the end there, but I hope the numbers speak for themselves. I'll upload this. It's your quiz tomorrow. No, it's your quiz. This one is going to be your quiz for Wednesday morning. Okay, good luck with it.